Okay, so today we'll conclude this part of the module where we talk about the short run. So from next lecture, probably we'll talk about the medium run. So let's see how we get on with the material. What I want to do today, first I want to just look back at what we did last lecture. Just to remind you, last lecture we talked about the ISLM model. We did some policy short-run or demand-side policy analysis. We talked about what happened when, for example, there is an expansionary fiscal policy. For example, the government decided to increase their government spending. How does that change the equilibrium output and the equilibrium interest rate? So we focus mainly on the process or the mechanism. How does that work? So basically having a higher level of government spending that has some implication to the goods market, where obviously we would have a higher aggregate demand, which means income increases. And through the Keynesian multiplier process, we know now, we understand that when income increase, consumption increase, and so on, and then again income increase. So we go through like several rounds until the effect dies out, and then we come to a new equilibrium point where output equal demand. In the money market, in the same time, so that increase in income that happened as a result of an expansionary fiscal policy, for example, increasing government spending. So in the money market, that means higher demand for money, and higher demand for money, of course, given the money supply or the real money supply, MS over P, that means interest rate should increase or should go up. And we explain at how modern central banks properly choose I. So in that case, we will take I as exogenous or as given by the central bank. But in this case, the adjustment process will happen to the money supply. So the central bank will allow money supply to change, or will change the money supply to achieve the targeted interest rate. Also, another example, if we have an expansionary monetary policy. So these are things that we discussed last time. So I'm not saying anything new. So that's why I'm just probably going a little bit faster than usual. So this is what we did last week, just as a reminder to everyone. So when we have an expansionary monetary policy, that means increased money supply. And increasing money supply, that means in the money market, money supply curve shift to the right. And that means the interest rate falls. In the same time, in the goods market, a lower interest rate means higher investment, and that means again higher income, because investment is part of the aggregate demand. You remember the components of aggregate demand. We have consumption, investment, and government expenditure. So having a higher level of investment, that means higher level of aggregate demand. And again, the whole process, the multiplier process, work the same way. So you have higher income, higher consumption, and then again higher income, and it goes in and out until we reach a new equilibrium point. Interestingly, we were interested also in talking about policy mix, because we could actually combine fiscal policy with monetary policy to achieve some policy objectives. So, for example, if we have a recession, so it doesn't have to be either monetary policy or fiscal policy. We could actually have a mix of both. And in this situation, if the economy is going through a recession and you want to boost that economy or stimulate the economy or take that economy back to recovery or out of recession, so you could follow or implement expansionary fiscal policy supported by expansionary monetary policy. And we know how that affects both IS and LM curves, and that will push the output up. So the output level, or the equilibrium output level, will be higher in that case. We give an example of this situation in the US 2001. We said there was a recession, and we explained the response by the Fed, or the central bank in the US. So they cut the interest rate from 6.5 to, by the end of that year of 2001, it fell from 6.5 to 2%. So a massive cut in the interest rate. So on the other side, the fiscal side, on the fiscal policy side, the government applied or implemented some expansionary fiscal policy as well by cutting taxes and increasing government spending. Again, that was a real example from what happened in the past, how policy, how fiscal and monetary policies can be mixed, or how can we have a policy mix that achieves some kind of objectives. So another point we also discussed last time is how we could have a policy mix that maybe can reduce the budget deficit and at the same time maintain the output level. In such case, we show that you could have fiscal contraction to limit or to reduce the budget deficit, but because we don't want investment to fall as a result of that. So what we did, we explained that we could actually also supplement this by an expansionary monetary policy. And in that case, the IS curve shift left because of the contractionary fiscal policy, and the LM, if you have a horizontal LM, that means shift downward. If you have a upward sloping LM, that means it will shift outward or to the right. So in that case, you could actually get rid of the deficit, or at least reduce the deficit, and at the same time maintaining the same level of output. So the final point that we discussed last lecture was about liquidity trap, or the zero lower bound of the interest rate. And we explained at that point, when the interest rate is very low, nearly zero, very close to zero, that makes holding money or the opportunity cost of holding money very low. So remember, before we discussed this, we said if people keep their financial, or they split financial wealth between two assets, money and bonds, money is a liquid asset but doesn't pay interest. Bonds pay interest. So but if that interest is very low, so that means the opportunity cost of holding money is very low. So which means people at that point will prefer holding actually money rather than bonds. And again, the reason is that the opportunity cost will be very low because the interest rate is very low. And that in such case would be indefinite money demand, which we explained that horizontal part of the money demand curve, which is very close to zero. And because that interest rate cannot go negative, so it cannot be negative, so that means monetary policy is not working, is ineffective at this point. Again, because if there's a recession, if the economy is going through a recession and you want to implement an expansionary policy, you can't actually, the mechanism that works through is how the interest rate affects investment. And in such case, having lower interest rate wouldn't be possible because it's already zero, so it can't go below that. So in this case, maybe you could use fiscal policy, or you could try to get the interest rate back to normal, which is always easy to say, but it's a very difficult situation. But if fiscal policy could be used at this point, if we have a recession and if you can apply expansionary fiscal policy to help, then maybe fiscal policy will be more effective at this point, or in this situation where we have very low interest rate. So that's everything we discussed last time. What I want to talk about today is we're going to move to more realistic situations. When we discussed last time, or so far, we actually assume there's only one interest rate. When we talk about assets or financial assets, we assume that there's only one type of bonds, and it's only money or bonds, and there's only one type of bonds. So these are things that we are going to change today, and we'll see how we can use this to extend the ISLM model, and then we'll see some example how we could actually use what we have learned so far to find out the equilibrium output, to work out the equilibrium output and the equilibrium interest rate. And we'll conclude the lecture by talking about how we can use this information to drive the aggregate demand, because so far we haven't talked about prices at all. So we take prices, fix it, we didn't change prices. So we talk about real money supply. So you talk about M over P. So we've been all the time taking P as given, so as constant, so we didn't change it. So today we'll change this and see how we can use this to drive an aggregate demand curve. So let's start with the first point, which is the normal versus real interest rate. So as we said before, as I said now, when we talked about financial markets, we assumed that we have only two financial assets and a single interest rate. Okay, so this is kind of oversimplified situation, because usually financial markets are more complex than that. So it's not only a single interest rate. It's not only we're not talking only about one type of bond. They are different. It's more complicated than that. So before the global financial crisis, the role of the financial system was downplayed in macroeconomics. But what we've seen in 2006, 2007, 2008, we've seen that financial system can go through some sort of economic or financial troubles, and this will have some implication to the overall economy. But before that point, the assumption was that the central bank can control the interest rate, and any other type of interest rate, or all interest rates will just follow the same. So kind of implementing the monetary policy was kind of a straightforward task. As we explained earlier, that if the central bank want to follow or apply an expansionary monetary policy, then they go to the short-term bond market or the open market operations. So when if they want to have an expansionary policy, they buy bonds, and if they want a contractionary monetary policy, then they sell bonds. But this was very, very simple way of talking about very complex thing, which is the financial markets. So today, or in this lecture, in this part of the lecture, we'll actually try to think more in a more realistic way about what actually happened in the real world. So we'll differentiate between nominal interest rate and real interest rate. So nominal interest rates, which often called quoted or stated rates, and this is different from real interest rate, and the difference here is the inflation rate. Okay, so just think of the interest rate or the nominal interest rate as the interest rate in terms of dollars or pounds, and the real interest rate, think of it as the interest rate in terms of a basket of goods. Okay, so if you want to obtain the real interest rate, or to know the real interest rate, you need to adjust the nominal interest rate to take into account the inflation. So if you buying a bond today, you basically lending your money, because you buy this bond today and you expect at some point or at the maturity date, so you get what you've paid plus some sort of interest. Okay, and to decide on how much you would like to have on this investment, you need to think of the inflation rate, because if the inflation rate is going to be higher than the interest rate I'm receiving at the end of this, let's say, of a year, that means actually I'm in a worse off situation actually. Okay, so my financial wealth actually decreased, because now it's actually the purchasing power of this is much less than how it was before. So what I would imagine, what I would want or I require as an investor, in a year's time, I want the money I invested or I paid in this, but also I want an interest rate that will cover the inflation rate and also will give me some sort of compensation, because I wait for this, or I use this money. I could have used this money in some other sort of investment. So I need a compensation for that time to wait for a year to get this money back. So basically, in that sense, if you're an investor, you actually not thinking about just the nominal interest rate. You're actually considering what we just called now the real interest rate. Okay, so the real interest rate now takes into account the inflation rate. And since I'm talking about the next year or the next time period or T+1, so basically we're not talking about the realized inflation rate, we're talking about the expected inflation rate. Okay, so when you make any decision, investment decision, you make it before or you make it now, but maybe the return to this investment will happen, let's say, a year later or 3 months later or 10 years later. So you need to decide now on what interest rate you would require or you would want to make this such investment attractive to you. So in that sense, you actually considering not the inflation rate, you're considering the expected inflation rate. What do you expect about the inflation rate over the next 3 months or over the next year or over the next couple of years? Okay, so depending on the maturity date of your bond. So in that sense, then to calculate the real interest rate, which we're going to call it small r. Okay, so we've been using I so far. So I here we mean, or we refer, so we're going to make that distinction from now on now. So I now means the nominal interest rate. R means the small r, the small letter I means the nominal interest rate. The small letter r refers to the real interest rate. So if I, the nominal interest rate, and the expected inflation rate, and by the way, the inflation is pi letter, the Greek letter pi. So that's the inflation rate. If I refer to the expected inflation rate, you'll see that E letter as a superscript on the top. Okay, so that refers to the expected inflation rate, not to the inflation rate. It's the expected inflation rate. Anyway, so if the nominal interest rate and the expected inflation rate are not too large, so we can have some approximation of the real interest rate, which you see now on the screen. So R approximately equal the nominal interest rate minus the expected inflation rate. The subscript here refers to the time. So when I talk about RT, so that means the real interest rate in time t, so the current now in this time period. That's approximately equal the nominal interest rate in time t. You see you notice the subscript t, okay, which is something we didn't use before, but now we introduce it now. So since we talk about expected, and now so it means there's time t and there's time t+1, okay. So in that sense, the real interest rate, as I said, approximately equals the nominal interest rate minus the expected inflation rate. So the expected inflation rate you see here, pi, and the with the superscript E, which means expected inflation rate, and t+1 means the next time period. So there are some implications for this equation here, or for this equality here. So when expected inflation rate pi here equals 0, that means real interest rate equal the nominal interest rate. But since inflation is usually positive, that means R, we expect R to be lower than I. So the real interest rate to be below the nominal interest rate. Okay, so any positive number here, so that means this R will be smaller than I. Okay, the real interest rate will be smaller than the nominal interest rate. Also, for a given nominal interest rate, higher expected higher pi here, or expected inflation rate, that means lower real interest rate. So Also, if we, because this expected, or this pi here refers to the expected inflation, this rate here, R here, is called the ex ante or before the fact rate. So that's the ex ante rate, so which means like before the fact rate, because it's something about something will happen, so it's expected. While if we use the inflation rate, so if we replace this pi here, if you replace this pi here with the, rather than the expected inflation rate, if we use the inflation, that means we have the ex post or the after the fact interest rate. Because in that sense, because we know now how much inflation rate was, that means we know for sure that how much that pi is. Okay, so that's why it's called the realized R. And again, it's based on inflation, the actual inflation rate, not the expected inflation rate. So anyway, so this was just some comments about this real interest rate, and also how does this affect, or how does this relate to what we have covered so far? So the interest rate will enter the IS relation is going to be the real interest rate, not the nominal interest rate. I know we haven't made this distinction so far. We didn't talk about the difference between real and nominal interest rate. We just put I, or the interest rate, in the IS relation. But from now on, it's going to be R. That's what actually, as I said, if I'm an investor now and I'm talking about a new investment, or I'm considering a new investment, I will be actually thinking about the real interest rate rather than the nominal interest rate. Okay, so the nominal interest rate is determined by monetary authorities or by the central bank, but as an investor, I don't really care about the nominal interest rate is not the main determinant of my investment decision. It's going to be mainly the real interest rate, because I care about inflation rate as well. I need to factor in inflation rate as well. So, and in that sense, the expected inflation rate, because I'm talking about an investment that will have some return in the future. So I'm talking about the future. So that means how much how I expect the inflation rate in time t+1. And also the zero lower bound, which we talked about, the zero lower bound condition of I, or the nominal interest rate. So that means I here cannot go below 0. So can you just imagine for a second I is 0. So this is the lowest it can go. Okay. So in that case, the real interest rate, RT, will equal minus pi E, or this is the negative of inflation. So that means R cannot go below that, or the real interest rate cannot go below that. Again, so just think of this. Well, this is the minimum, or the lowest it can be is just 0. It can't go below 0. It cannot be negative. So in that case, this is how small the R can become. Is just minus pi E, or the negative of the inflation rate. So these were some implications to what we know now. So just let's just sum up what we said so far. Okay, before we look at some example and see how this R, how this will extend our, how we're going to extend our ISLM model using the new information now, or what we learn now about the difference between real interest rate and nominal interest rate. So, as I said before, we didn't make this distinction. We just assume it's only there's a single interest rate, but this is not true. Okay, so the difference here, the main difference here, is that the real interest rate takes into account the inflation rate. And to be more accurate, we talk about the expected inflation rate. Okay, so to calculate the inflation, the real inflation rate is the nominal inflation rate minus the expected inflation rate. And there are some implications to this equation, or to this relation. So when expected inflation rate is 0, so that means both are the same interest rate. So real interest rate equal the nominal interest rate if expected inflation rate is 0. And because inflation is usually positive, then we would a positive number, so that means the real interest rate will be smaller than or lower than the nominal interest rate. And given that, given any level of the nominal interest rate, we would expect that higher expected inflation rate would mean lower real interest rate. We talked about this, the difference between ex ante interest rate and ex post interest rate. The difference here are using the expected inflation, or it is the inflation rate. And finally, we'll talk about how this is related to our IS model or ISLM model. So that means, remember, there's investment, and investment depends on, we said, on the interest rate. But today, we know that investment depends on the real interest rate. Okay? To make a decision, to make an investment decision, you consider the real interest rate because you need to take into account the inflation rate. Okay? So you're not just looking at the nominal interest rate, you're actually considering the real interest rate. And that's what is going to enter our IS equation. Okay? Okay, so this shows us the relationship between both in the US since 1980s. Okay? So what we see here, the red line shows us the nominal interest rate, and the blue line is the real interest rate. And this is for 1 year Treasury bill rates in the US, as I said, since 1987. And you can see is both are declining, the nominal interest rate and the real interest rate, but you can see because of the inflation rate or the expected inflation rate declined as well. So that means the real interest rate, you'll see, declined much less than the nominal interest rate, because the nominal interest rate was really high at the beginning of this period, and then you see is declining really considerably compared to how it was a few decades ago. But then when you look at the real interest rate, is declining by much less than I. And again, it's all about the expected inflation rate. Okay, so again, so all what we said so far, we said the assumptions we made before about financial markets. We assume there are only two assets. Okay, these assumptions that we're going to change today, or we're trying to change today, make them more closer to reality. Okay, so two assets, only one type of bonds, which is not true. We assumed only a single interest rate, which is not true. Okay, well, at least now we know the difference between nominal interest rate and real interest rate, and which one is considered by investors. So basically, investors look at or consider the real interest rate. So the central bank decides the nominal interest rate, which we said it's often called the stated or quoted interest rate. So that's what is decided by the central bank. But what is considered by investors is actually the real interest rate, which takes into account inflation rate. Okay, but there's also one more thing that investors take into consideration in addition to the real interest rate, which is risk. Okay, so when you buy a bond, you actually there's so many risks involved here. Okay, so what we're going to talk about now is risk and return premia, which is the return that is required because by investors. So how investors decide on whether to take on a new investment or not, whether to invest their money in a new bond or not. So number one, we talk about, they look at the or they consider the real interest rate, okay, not the nominal interest rate. But also, there's also risk, the risky factor they need to consider, how risky that investment is, okay? Because when you buy a bond, you're lending your money out. So there's a chance of that the whatever firm or the bond issuer or they'll go default, and then you're not going to have your money back. So there's some sort of risk involved. So what I want to say here is that what we assumed before, that there is only, when we talk about financial markets, we said there's only money and bonds, and then we just consider all bonds the same, which is not true. Okay, so so far we assumed one type of bond, which is not true. As I said, bonds differ depending on several factors, including the maturity date and the default risk. Okay, so if you have a 3-month bond, is different from a 1 year or a 10-year bond. So you need to think about these are the factors that actually you need to consider when you make a new investment in bonds. So some bonds are riskier than others. Usually the government bonds are risk-free, so they are riskless, so they don't have risk, because the chances that government will go default is really low. So usually we take the government bond rate as a kind of an indication of a risk-free asset. Okay. So bond holders basically require an interest rate. You remember, so it's not just the real interest rate. They also need to consider the an interest rate, or they want an interest rate that will cover, or they will compensate them for how long they will wait, and also will compensate them for the probability or the chances that this bond issuer will go default. So the default risk. So how to take this into consideration? How to integrate this into our model? What we've done so far, the ISLM model. So let's first think of how much investors will require to take on a risky asset or bond. So basically, they would consider something like, okay, if this is the expected return on a riskless asset, so a risk-free asset. So let's say I here is the interest rate on treasury bills or on a government bond. So we agreed that government bonds are risk-free. So if the interest rate on these bonds that has no risk is I, okay, then to have the same expected return, you need to keep in mind the probability of default. So if the probability of default is P, so this part of the equation here, this part means that the bond issuer has default. Okay, so that means how much return you will have if they go default is 0. There's no return. Okay, so that's the probability of default times the return that you would get, which is 0 in that case. Okay, plus the 1 minus the probability of default, which is 1 minus P, times the return. In that case will be 1 plus I, which is exactly the same as a risk-free asset, but also you will add X. X here is called a risk premium. Okay, so if, for example, a risk-free asset offer you 4%, that's I, then for you as an investor who's going to invest on a riskier or relatively riskier asset, okay, then you would require an interest rate that is higher than 4%, okay, to compensate you for taking on this sort of risk, okay? And that is the difference between the rate that you will ask for, or the rate that will make this investment attractive to you, compared to the risk-free interest. That is called the risk premium, okay? So you ask for this extra because you know that this asset is a riskier asset compared to risk-free. So it has some risk. So I need to ask for a higher premium, okay, risk premium. So in that case, we could actually work out how much that X or that risk premium would be. And from that means it will be 1 plus I times P. Remember, I here is the risk-free interest rate, and P here is the probability of default for the other risk, for the other bond that you're planning to invest in. And then over 1 minus P, that's 1 minus the probability of default. Okay, so now let's just go back to the basic now. So the main idea, I just don't want you to get lost in details. Let's just look at the big picture. What we're trying to do here, we're trying to have a more realistic picture on how investors decide on their investments, because investment is part of our, remember, IS, yeah? So when we talked about the IS equation, investment is there, okay? So we want to know how investors decide on taking a new investment. So it's not just they don't consider just the nominal interest rate, they actually consider the real interest rate rather than the nominal interest rate. They also add to this the risk premium, because remember, all bonds are not the same. So there are some risk-free bonds, usually the government bonds, and other bonds will involve some risk. So if you are going to invest on a bond that has a higher risk, you probably will, or you actually should, ask for a higher interest rate to compensate you, okay? And what you see on the board here, on the screen now, is just a very simple formula to show you how you can actually calculate how much risk premium you should ask for, okay? So basically the minimum, or what you're going to ask for, is what makes the expected return on your investment equal the expected return in your risk-free assets, which is 1 plus I in that case. So I here is the interest rate in the risk-free asset, okay? So on the other side, you have two terms here. So this part, which is P times 0, is exactly, that's the probability of default times whatever return you will get, which is 0 in that case. So in that case, in the other, plus the probability of not default, so that's 1 minus P, times, this is the return for a risk-free asset, plus some X or plus some premium, risk premium. And from here you can get how much the risk premium should be, and using this form. So in that case, then we know that risk premia are determined by two things. The probability of default, okay, which is P, okay? So obviously, higher probability of default should be associated with a higher X or a higher risk premium to make this investment attractive, or to attract investors to buy this bond, okay? And also, it depends on the degree of risk aversion of bondholders, okay? So people are different in terms of their perception of taking new risk, okay? So some people would probably, so the more you are risk averse, the more, or the higher the risk premium will be, the higher X will be, okay? That's what you would require, that's what you ask for to get or to buy this bond, okay? Obviously, the less risk averse you are, then the X will be lower, okay? So anyway, so now we know what determines the risk premium. Again, what I'm trying to say here is we are interested in this because we want to extend our ISLM model to a more realistic situation where we have more than one interest rate, we have this distinction between nominal and real interest rate, and also we have this distinction between different bonds depending on how risky they are. Okay, so this graph here show you the three types of the interest rate of three types of bonds. So the 10-year US government treasury bond, which is the yellow one, or the lower one, which is the risk-free one. Okay, that's the return on these assets or on these bonds since 2000, and the other two are kind of rated. So AAA means less risk. Triple B, that means riskier than AAA. Okay, so AAA is better than triple B in terms of how much risk it has. So you'll see that the return or the interest rate on the risk-free, which is the yellow one, is always below the other two. And then comes the AAA, which is kind of a safer investment, okay, compared to the red one, the triple B, which is a riskier investment. Okay, so that's exactly what this tells us. So usually you ask for a higher rate for when you have a higher probability of default. A higher rate, the AAA for less or lower probability of default. And then because it's safer, then you ask for a lower return or a lower risk premium. The government bonds are always below this because it's risk-free. And these are the takeaway messages from this graph or from this section, what we said so far. So bond rate vary depending on several factors. We talked about the maturity. We didn't discuss how that affects the interest rate required, but we focus mainly about the risk, okay, the risk premium. Investors demand compensation, so higher I to take on more risk, so higher interest rate to take more risk. Anyway, so that's what we said so far. So how are we going to use this information to help us to extend our ISLM model? So let's go back again to what we said. We said the first point or the first section of the lecture, we said we should make the distinction between nominal interest rate and real interest rate. And what investors care about is the real interest rate, because the real interest rate take into consideration the inflation rate. Okay? And also one more thing investors consider, which is how much risk they have to take on to have a new investment or to take a new investment. And now we understand the risk premium. Okay, and how we calculate the risk premium, we call that X. So now what I want to do before we finish off this part of the lecture, I want to see now how we're going to use this, how we're going to plug this into our model, ISLM model. Okay, so now we want to update our ISLM model to reflect the distinction between nominal and real interest rate, and also between the policy rate, which is determined by the central bank, and the rate that borrowers face. Okay, so remember, borrowers usually face a rate that take into consideration not just the nominal interest rate, it take into consideration the inflation rate and the risk premium. Okay, so two more things that we consider. So the policy rate just is different now from what the actual rate that borrower face when they borrow money. Okay, so these are two different rates. Okay, so in the first equation here, so this is our IS model or IS equation, IS relation, where Y depends on consumption, and consumption we know depends on disposable income, which is Y minus T. Plus, that is what we are interested in this lecture, investment. Okay? Remember, when we started talking about this model, we just consider investment as exogenous. We didn't really discuss what determines investment. Last week, we said no. To drive ISLM model, we said no. Investment depends on interest rate. And we assume that there's only a single interest rate. There's only one interest rate. But today, we say no, this is not true. Now we relaxed this assumption that we made last week about a single interest rate. Now we say, hold on, borrowers are faced by interest rate that's equal to I minus expected inflation rate, so this is the real interest rate, plus risk premium, which we called X. Okay? So in that case, this is how, or this is what determine investment plus G. G we always treat G as exogenous or determined by the government. Okay? And on the other side, monetary policy or the LM curve. You remember we treated LM as a horizontal line because we assumed that interest rate is given by monetary authorities. So in that case, if we bring this model more or closer to the real world, so the central bank chooses real policy rate R. However, what enters the IS model, the IS equation or IS relation, is R, which is the real interest rate, plus some X premium, which we called X, that borrowers face, either they were consumers or firms. So in that case, this is our IS LM model. So the first equation is the IS equation. The second equation is the LM equation. Okay? So the first equation, what is different here is that we included these factors that determine investment. So we're not treating investment as exogenous anymore. Investment here depend on Y, depend on also the interest rate that is considered to take, that investors consider when they take on a new investment. They consider the real interest rate plus the risk premium. Okay? So how that change our model? How that change our understanding of the ISLM model? So basically now spending depends on R rather than I. So spending depends on the real interest rate rather than the nominal interest rate. And also we added the risk premium that captures the perceived risk and the level of risk aversion of bondholders or investors. Okay? Is that clear? Okay. So in the next part of the lecture, what I'm going to do is to show you how this, if there's a change in the risk premium, how this is going to affect our ISLM model, and also we'll carry on with the other points. Any questions? Okay, thank you. See you next lecture. In the first part of this lecture, we extended the ISLM model. What we have changed here is, one, we made a distinction between the nominal interest rate and the real interest rate. And also we talked about how investors or how bonds are not the same. They differ based on maturity and default risk. So we show also how we are going to include this in our ISLM model. So that's what we changed in the IS equation. Now we have investment depends on the interest rate that borrowers face, which include the real interest rate R plus a risk premium we called X. We also explained that the central bank determined the policy rate R, or determine R, but borrowers face an interest rate which is R plus X. So what we want to look at now is how this, if X change, if the risk premium change, how that's going to affect output and the equilibrium. So because higher risk means the IS curve will shift to the left, so higher risk premium X means the IS will shift to the left, because that means lower investment, and that we know that lower investment will just shift the IS curve to the left. So in this situation, we move from equilibrium point A to equilibrium point A prime, where the new output or equilibrium output here is the Y prime, which is less than Y. Again, what has caused this shift is a higher or an increase in the overall risk, which of course investors will require a higher risk premium to take on investments. So this change in the risk premium, or this change in the overall risk, which led to higher X or a higher risk premium, could be offset using either government spending or fiscal policy or monetary policy. So, meaning in that case, if we have if we apply an expansionary fiscal policy, maybe that could help to shift the IS back to the right, going back, so offsetting the effect of a higher overall risk. Or it could be done the same by just shifting the LM curve through the monetary policy, which this is exactly what this graph suggests. So this is exactly the same situation where we have a higher overall risk, which led to a shift in IS from IS to IS prime. So to offset this, meaning to go back to the same level of output, we could do that through fiscal policy or monetary policy. So here, this is an expansionary monetary policy that pushed this LM curve downward. However, something that we highlighted in the first lecture, we discussed again and again over the last few weeks, is that the zero lower bound can limit or may limit the change in R here. So we might not be able to reach this point because, remember, what is R here? It's I, the nominal interest rate, minus the expected inflation rate. So when we have a very low I, so that means we might not be able to, or monetary policy might not be able to help us to go back to the same level of equilibrium output. But anyway, so what we show so far is how to extend the ISLM model considering real interest rate rather than the nominal interest rate, and also considering the risk premium, which investors or bond holders usually require as a compensation to take or to buy or to take on a riskier investment or a riskier bond. Okay, so what I'm going to do now, there's two things I would like to do in this part of the lecture before we finish. So the first part now, or what we finished so far, is or has only one takeaway message, like the main message or the key message, is the way we factor in risk and real interest rate in the IS equation. Okay, so it's very straightforward. Now we understand there's difference between nominal interest rate and real interest rate, how we calculate the real interest rate based on the nominal interest rate minus the expected inflation rate. What would happen to the equilibrium, if there's a higher overall risk in the economy, how this will shift the IS to the left, and this will, that means Y will fall, or the output level will be lower. And this could be compensated by fiscal policy or monetary policy, but we put this comment on having a very low, already very low interest rate, nominal interest rate, might not be very helpful in this situation. Okay, so what I want to do next is to show you an example of how you could use this to find out or to calculate, rather than doing this using the graph. So what we show so far is just how do you find the equilibrium point using the graph. You could do the same using the equations or some algebra, that's what we learned before. So for example, if this is the consumption function and this is the investment function, which again has some autonomous or independent component here, which is independent from the interest rate, and some kind of a factory, which is our coefficient here is like 80 minus 80 times R. And we said before, this is a negative relationship between the interest rate and investment, which that's why this is a negative number. G, or government spending, will treat it as exogenous or given. It's 500 million or billion pound. And then T is 500. And the money demand, real money demand, is given by this equation. This is the money supply, this is the price level. So if we have this information, how could we work out the equilibrium output and the equilibrium interest rate? So we want to find out Y and R. So what you have in the books on the right here is just the information we have about this problem. So basically, we could just find the equation for the use the equation for the IS curve and then LM curve, and then just make both equal, then work out how much R is, and then you substitute this in one of the equations to get Y. So let me do this, just show you the example how to do that. So we know that Y depends on consumption, and that consumption here depends on disposable income, which is Y minus T, and this is I, or investment, which depends on interest rate, real interest rate. I didn't include the risk premium in this example, so if it was there, so it should be straightforward to add, but what we have here is just real interest rate. And government spending. So what I did here, I just put these in color so you can recognize it. So this is basically the consumption function, which is given here in the question. Y is unknown, but I know T, I know taxes is given here 500. The red color here is the investment function, which is given here, plus 500, which is the government spending. All what I need to do here is to find out how much Y is, which is now, I guess, is very straightforward. So I want Y, because I have two variables here. I want Y and R, so I need Y on one side and R on the other side. And that would give me the IS equation. So this is just straightforward from what we have here, and this just get, as I said, Y in one side and R on the other side. And basically what you have here is the IS equation. So the IS equation here, Y equal 3000 minus 200R, okay? So this is one equation. In a very similar way, we could do the LM equation. So the equilibrium In the money market, we know in real money supply equal real money demand. So we already have the equation for money demand, and we know that money supply is 3,000. The price level is 3. So then we can work out the real money supply. So in this, so that means 3,000 divided by 3, that will give us 1,000. So that's the real money supply. And this is on the right-hand side here, we have the money demand. So all what we need to do is, again, to write down the equation for the ISLM the same way. So we want y on the left-hand side and r on the right-hand side. So from here, you can basically find out that this is the equation for ISLM. So it's y equal 1,000 plus 200r. So remember, so what we have here, we have y, and or this is IS curve, and this is ISLM curve. So what we need to do now to find the simultaneous equilibrium in both markets, you just need to put these both together. So the IS and ISLM. So we've got two curves now, the IS and ISLM. All what I need to do is to put these together and then work out how much the interest rate is, which is R here in this equation. So from here, you can find out how much R. So the equilibrium interest rate, real interest rate, in this case is 5%. Okay? What do you need to do next is to use that in any of these equations, in the IS equation or the ISLM equation, and then find out how much y is. Obviously, if you put 5 here, that means 1,000, so 3,000 minus 1,000, that gives us 2,000. So that means the equilibrium output is 2,000. Okay? So you need to practice that. You need to do it yourself. Okay? So what I'm trying to do here, just to show you how to do it, and there's also in the tutorial next week, there'll be questions similar to this. Okay? And as I said in the seminars today, the class test, the question that you'll see in the class test are very similar to the tutorial questions from this week and the next week, which is very similar to what you see in the screen. So what you need to do is just to practice this at home again. Okay? Do it yourself and practice at home. I will also post a mock test on Learning Central, so you can practice. I'll post it along with the solution. But my advice is to do it yourself first before you look at the solution. So let me just move from here just to show you how then we could plot the equilibrium using this information. So we know that the interest rate, the equilibrium interest rate is 5%. The equilibrium output is 2,000. And that's LMIS using this information. And of course, this is what R is 5. And the equilibrium is 2,000. So how did we get these 2 points? Does anyone know? This 1,000, this 3,000. Where do we know this? How do we know these values? Just go back to the equation. So if R here equals 0, how much Y will be? If R, this one, equals 0, how much Y will be on the IS curve? 3,000. That's 3,000 on the IS curve. Okay? How much Y will be if on the LM, if this R equals 0, that means this would be 1,000. Okay? Which is exactly what you have here. Okay? So that shows you how to plot it accurately. Okay? So let's now, now you can play with it. You could actually say, what if there is an expansionary fiscal policy? How would that situation change? So, for example, here I said, assume that now government spending has increased from 500 to 700. How the IS will respond to that, and then how the equilibrium output and interest rate, real interest rate, will change as a result. So all what you need to do is to use the new information now. So we have here, rather than adding 500 instead of G, I actually changed that to 700 because we know government spending is part of the IS equation. So all what I did here, just I added the new government spending, and then that would give you a new equation for the IS. So you'll see this equation is 3,500 minus 200R. If you compare that with the equation we had before, is 3,000. So the position of the IS has shifted to the right because of that change in government spending by 500. Because it was 3,000 here, it moved to 3,500. So it's it shifts to the right by 500. You can use this to find the equilibrium interest rate following the same steps. Okay, and that will give us the equilibrium interest rate is 6.25%. And the equilibrium output is 2,250. Okay, how did I know this? All what you need to do is to use this information here, that the R, or the value that you found for R, and you plug this into one of these equations, either the IS equation or the ISLM equation, and that will give you how much Y is. And you can plot the equilibrium, of course. This is the change here, or this is the shift. So this IS curve shift from IS1 to IS2. We've got a new equilibrium point where R has gone up from 5 to 6.25, and the equilibrium output has changed or has increased from 2,000 to 2,250. The position of the IS moved from 3,000 here to 3,500 at this point, and that was as a result of the change in government spending by 200. Okay, so that should be straightforward, but you need to practice and try it by yourself. I'm not going to do the second case when money supply change, but it should follow the same logic. Okay, so what we saw now is just an example how we could do exactly the same thing. A change or a fiscal policy change, or a change in fiscal policy or change in monetary policy, and then see the effect, how that would affect equilibrium output and equilibrium interest rate. Now, the last point I want to cover in this lecture is how we can use this to drive the aggregate demand curve. But before we jump to that point, you need to see where the link comes from. What we did so far, we didn't really assume that, or actually we assumed that price has changed. The prices haven't changed, so the price level didn't change. So where do prices enter our model, IS and ISLM model? Does anyone know? Where did you see prices in the model? Which side, the IS side or the ISLM side? Where did you see P, prices? Yes, thank you. The ISLM side, okay? Going back here, when we calculated this, you see MD over P, that's the real money demand, and to calculate equilibrium, we needed the money supply over P, so again, real money supply. So that's where P entered the model, okay? So far, we didn't mention anything about change in P. We just took P as given or as exogenous or doesn't change, constant number. But now it's time. So far, we treated price level as fixed. But now, if there's a change in prices, as you said, because it enters the ISLM side, so that means ISLM curve should shift. Okay? So if prices change, that means, or the price level change, that will shift ISLM curve. And obviously, if ISLM curve change or shift, that means the equilibrium output will change too. Okay? So From your study in microeconomics, you probably can imagine or you can guess aggregate demand is a relationship between price and quantities or output level. Okay? When we talk about the aggregate level, so we're basically capturing the relationship between the prices and the output, okay, or income level, because we know income is the output. Like both variables are the same. So what I want to show you now is how you can use this information to drive the aggregate demand curve. So the first section, or the top section in this graph, shows us the equilibrium point. Just notice that we have here upward sloping LM curve. Okay? So it wouldn't really change much if we have if we carry on with the assumption that central banks decide or choose the interest rate and then they change or they adjust money supply. But for now, let's just follow the traditional way of thinking about the LM curve and its upward sloping curve. So the equilibrium, or the initial equilibrium point, because that will change now or will change soon, where at this point where LM intersect with IS, and the given level of prices here is P1. So what we need to do here, we have R1, this is the equilibrium interest rate, or initial equilibrium interest rate, and this is the initial output level, and I just identified this point on the PY space. So this is P1, this is Y1. So what would happen now if the prices change? We said the LM curve will change, will shift. So now let's assume that prices, or the price level, has gone up, has increased. Okay? That means the real money stock, or M over P, will fall. Okay? Because this P now is higher, so that means the whole fraction will be less, will be smaller. And that means LM will shift to the left. So now, having LM shift to the left, we have a new equilibrium point, and that means a higher interest rate and a lower output level, which means we move from Y1 to Y2. Remember, here P2 is higher, so we just identify this point in the PY space. So P2 is higher than P1. This is our assumption here. This is what the change that we suggested here. And then as a result, Y here has dropped from Y1 to Y2. Now I guess you can guess now what I should do now. We just connect these 2 points. That will give you the aggregate demand curve. Okay? So downward sloping curve, as you might expect. So what we changed here is the price level. And then we'll see what would happen to the equilibrium output, because changing the price level affect real money stock, and that means the LM will shift. The LM curve will shift. Okay? So if the price level increased, that means the LM curve will shift to the left, which is the example we just showed now. And that means using these 2 points, we could actually drive the aggregate demand curve, which is a relationship between P and Y, or Y and P. So the price level and output level. Is this clear? Any question? Okay. We could also use this to see what would happen if there is a policy change. How this aggregate demand curve will respond to a policy change. So in this example here, I just showed if there's a monetary expansion, so increasing monetary or money supply, and I just kept P the same level, or the price level the same, P1. So Given that now we move from M1 to M2, or a higher level of money supply, so that means the LM curve will shift to the right, and that means we move from this equilibrium point to this equilibrium point. And basically what happened here is that the aggregate demand curve shift upward. Why? Because at the same price level, P1, what we have here is Y2, which is higher than Y1. So that means basically shifting the aggregate demand curve to the right. So this is as a result of an expansionary monetary policy. The aggregate demand shift to the right. And in other words, what we have here, we have at every or at each value of P, we have a higher output level. So at this P1, we move from Y1 to Y2, and that will apply to every level of these prices. So that means basically shifting the curve to the right. Looking at how would that work if we, is that clear? So the idea here is that how would the aggregate demand respond to a change or a shift in policy, in monetary policy? We could do the same with an expansionary. Obviously, you could do the same with a contractionary monetary policy, and that means the aggregate demand curve will shift to the left. Because looking at this case, you will see that if money supply falls here, so if M is lower now, so that means LM will shift to the left, so we'll move to this direction. So that means as if we move from Y2 to Y1, meaning that we have a lower output level at each value of P, which means that that means the aggregate demand curve has shifted to the left. So this was just the opposite case. So if you understand this case, you should be able to do the opposite case when we have a contractionary monetary policy. Similarly, we could do this with an expansionary fiscal policy, and if you understand how to do it with expansionary fiscal policies, it's straightforward to do with a contractionary fiscal policy. So having an expansionary fiscal policy, meaning increasing G, government spending, or decreasing taxes, which increases aggregate demand. Okay? So how that work? As we explained before, changing or expansionary fiscal policy will mainly be reflected in a shift in the IS curve. So IS curve will shift to the right. So we moved here from IS1 to IS2, which means now we have a higher output level. So we move from Y1 to Y2. Okay? Now we didn't change the price level. Remember, this is a given price level, which is, let's say, P1. So that means at each value of P, we will have a higher output level, which means that the aggregate demand curve will shift to the right. So I didn't do anything new today with these graphs. The only difference is we're showing what happened to the aggregate demand. Okay? So whatever change you've seen on the top section of these graphs, these two graphs at least, this is something you should be familiar with from before. So that's what we said before, how an expansionary monetary policy will affect equilibrium in both markets, in the IS and LM, and how would an expansionary fiscal policy would change that as well. So what we added to this, if you wish, what we added to this is that how the aggregate demand respond to these changes. So in words, so basically when you have an expansionary fiscal policy, so you would imagine that a higher aggregate demand, a higher level of aggregate demand. So that means aggregate demand shift to the right. Okay? If you have a contractionary, so even forget about these graphs now, just think about it. Okay, that's what we learned so far. An expansionary fiscal policy okay, means a higher demand. So that means aggregate demand will shift to the right, so it'll be higher. Contractionary fiscal policy, the aggregate demand shift to the left. Expansionary monetary policy will have similar effect. So aggregate demand curve shift right. Contractionary policy or monetary policy shift the aggregate demand to the left. Okay, so that's exactly what these two graphs say to us, or explain. So basically is how aggregate demand, or how the aggregate demand curve respond to a policy shift. The final point, which I will conclude the lecture with, is we could actually use the same example we followed before to see what would happen to Y and R, so the equilibrium output and the equilibrium interest rate, if we change the price level. Okay? Remember, where does the price go in the model, in the ISLM model? Which side? So it appears, we see it clearly, it appears, or explicitly enter that, the LM side. So when we talk about real money supply and real money demand. So what we trying to find out here is what would happen if that price level changed from 3 to 5. What would happen in this case? And we're mainly interested in what would happen to Y, the output, the equilibrium output, and the equilibrium interest rate. So obviously we need to consider, or we need to adjust, which equation we need to adjust, LM or IS? The price has changed, so that means we need to adjust the LM equation, okay? So in that case, you will see that if you want to calculate the money, the real money balances, or you will see that MS divided by, rather than divided by 3, so it was 1,000, now it is divided by 5, which means it falls because of that. So it became 600. So now you have a new LM equation. All what you need to do is just this equal the IS equation. So you put these together. That will give you the new equilibrium interest rate. Once you have the new equilibrium interest rate, use any of the either equations, IS or LM, to find out the equilibrium output. And you could show this on the graph. How would that work in the graph? Obviously, now we have a shift in the LM curve from LM1 to LM2, and that happened because the change of the price level. Okay? So now we have a new equilibrium point in both markets here. We have R, or the equilibrium interest rate, at 6%, and the output level fell from 2,000 to 1,800, as we see from this equation here. So what we could do here, we could actually use this. Now we have the equilibrium at when the price level was 3, and the equilibrium when the price level was 5. So we could use this to drive the an equation for the aggregate demand. So what we exactly did here is exactly what we did here, okay, to drive this line here, or the aggregate demand curve. But rather than showing that on a graph, I want an equation that represents that. So given the information we have, we could actually work out an equation for aggregate demand and plot the aggregate demand curve more accurately, not just representing the aggregate demand by a downward sloping line or curve. So the simple way to do that, first, we know the aggregate demand is a relationship between P and Y, or the price level and output level. So how we could use the information from the ISLM model to derive that using like algebra or equation rather than rather than graphs. So basically what you need to do here, you need to solve both equations and try to get y as a function of p. So output level, which is, just think of it as Q. In macroeconomics, you would have output or Q as a function of the price level, okay? So once you do that, then you find R, and then you use that to calculate or to have an equation of the aggregate demand curve. So let me just quickly show you how to do that. So basically what I did, first step, you need to find, just rearrange the IS equation to get y in terms of p. Rearrange the same, do the same for the LM curve. So what I did, this is the IS here. All what I did now, I just get this again in terms of R, so R on the left-hand side. I did the same here, R on the left-hand side. So basically, that means 3,000 minus y equal y minus m over p. All what is left now is to get y in terms of p, which is exactly I did here. So these are the two equations. So this is the IS equation, the left-hand side, the first line, sorry. And this is the LM equation. From here, all what I need to do is to get y in one side, or y in terms of p, which is the aggregate demand or a demand curve. So it's y in terms of p, or output in terms of price level, which is exactly what we have here. So this is the final equation, which tells us the aggregate demand equation. We could use this to plot the aggregate demand. So what you need to do is to give any values here for p, and then find the value of y. So let's say if p here is 0.5, how much y would be? If p is 3, how much y would be, etc. And that will give you exactly the aggregate demand curve. So what we have here represents exactly this equation here. So what we have, when the price is 0.5, y, or the output, is 4,500. When you change that to 1, then the output is 3,000, etc. So you get a few points, and then you connect these points, you obtain the aggregate demand curve. Is that clear? It's not going to be clear. You're not going to learn it before you do it yourself. So you have to do it yourself. When you go home, just try to work it yourself and see if you can do it. If you have any questions, or if you need any help to do this algebra or even the graphs, just let me know, and I'm happy to help with this. Okay? Any questions? So just to let you know, I have received many questions about the strike. So if there's any change, there's no change to the lectures or the seminars. Lectures and seminars are going as usual. I'll see you next time on Friday, and then next time we will talk about the labor market. Thank you.